All right, guys, here's a little video on the radial line worksheet that I sent out as well. I think for the most part, people did or are having not a hard time with this one, other than the blank size section. When it comes to laying out or doing radial line work in the shop, when it comes to the blank size, if you can figure out this chord length, that gives you the width of the blank size automatically. And if I had like this fitting here where it was 20 to 10 or 20 inch round to 15 inch round, 10 inches tall, if I know it's going to be 10 inches tall, I would just cut a piece like 12 or 14 inches wide just to make sure it's, you know, a little taller than what the finished product's going to be. And that's usually good enough. I am going to show you how to figure out this blank size exactly, but we'll first go through all of these measurements that are on that worksheet. So the first thing they're looking for is the apex. So this is the third one on the worksheet, these dimensions here. I find it often handy to draw a little picture of what we're doing. So if we use that apex formula, large diameter times the height, divided by large diameter minus small diameter. If you do it specifically like that, like you have to do large diameter times height equals, and then large diameter minus small diameter. So it's going to be 200 divided by 5. So the apex there should be 40. Then we have the slant height for large diameter. So that's going to be the slant height here. So that's just a squared plus b squared equals c squared. So if I actually drew a triangle in there. So I have an apex height now because that's what I figured out. So if I take that triangle and put it here, the base of my triangle is going to be 10 because it's half of the 20. The height here is going to be 40. So it's going to be 10 squared plus 40 squared is going to give me the slant height. And that ends up being 41 and a quarter. The slant height on the small diameter is just this little triangle up here. Right? So that is basically the large triangle, like the height here, the apex height, minus the 10 inches is going to give us the height of the small one. So that one ends up being 30 inches there for the small triangle. And then half of the smaller diameter is 7.5 inches. So this ends up being 7.5 on that one. 7.5 squared plus 30 squared, and the square root of the hypotenuse gives us 30 and 15/16. Okay, now we have those slant heights. This is the most important slant height that we're using for these math equations. This one does play into helping us find the blank size. Okay, so stretch out angle, that's where we use the other formula here. Stretch out angle is 180 times the large diameter divided by the slant height. So if you do that in your calculator, like put in the appropriate things in there, 180 times 20 divided by 40 or 41 and a quarter, that will give us a stretch out angle of 87.313 degrees. And with that stretch out angle, then I can find out these chord lengths, right? So this is 87.313. And remember, doing a chord length, if we draw a triangle in here, then I can actually figure out this chord or half of the chord length. And I can do the same thing for the small side, right? Little triangle in there, it's going to figure out half of the chord length. So that triangle, I'm going to pull out the big one here first. So here we have an angle it's going to be 87.313 divided by 2, right? Because we've cut the angle in half. So now we have an angle of 43.6565. That's our angle. We have a hypotenuse length here, because that's going to be this length of the triangle, which is our slant length, right? From here to here is our slant length, because that's the length we use to swing this whole arc here. So that's going to be 41.25. And then if we use the sine function and do the math on there, we can find out this length here. And then we'll multiply it by 2 to give us a total chord length of 56 and 15/16. Right? And we can do the same math using that same angle, but our smaller slant length, to figure out the small chord length, which ends up being 42 and 11/16. Right? Now with the blank size, I've drawn it here in blue. You can see the widest point of the blank sides is the same as the large chord length. So automatically we have half of the blank side size. So if the large chord length is 56 and 15/16, that's part of our blank size. The other one is going to be the height here. So we know that this slant length, if I bring it all the way down to the middle, that length there is the same as this length here. So from the bottom all the way to the top there is the slant length height. So what I basically need to do is subtract this length here off of that total length, and what I'm left over is going to be the height of my blank size. Hopefully that makes sense. So again, I have this little triangle in here. So I've moved it over here. So this hypotenuse of that little triangle is the small slant length. The measurement from here to here is half of the small chord length. So this the small chord length right here. Oops, right here. Sorry. Half of the small chord length is going to be on the bottom here. So 42. 21 and 11/32. So, and then the slant length, the small slant length was 30.15/16. So I can just go c squared minus b squared equals the square root of a squared, right? And that's going to give me a length here. I'll just do it here on my calculator. So that's 22. So this length is 22.06312. And then I can just subtract that off of my large slant length. And my large slant length was 41.25. So 41.25 minus 22.06312. And that's going to give us, wait a sec. I think I did something a little bit wrong there because my answer doesn't quite match. Anyway, I must have entered something wrong in my calculator. That is the way to do it. So give it a try yourself, and you should come up with 18 and 7/8. I must have hit a wrong button there. So getting that length there, subtracting it off the major slant length, should give you the actual blank size. And like I said before, it's not really worth, it's a lot of math for very little result. And you know, if I have my cord length width there for the blank size, and just pick a piece of metal that's slightly longer than the actual finished height of my cone, like I said, 12 or 14 inches, I'm gonna be able to lay this whole thing out on there and still have minimal waste. So, you know, if you're really good at math, it might be worth doing, but for the most part, I usually tell people it's not even worth doing. So anyway, if you have any questions, give me a call or an email, and I will do my best to answer.